David Smith here with another Flip Classroom math lesson. 3 tips before we start. First, you can adjust the playback speed to suit your ability to consume the video. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Today's lesson provides you with more practice finding the area under curves using this process we call integration, which is integral calculus. So, and then I put a little parentheses here. We're going to do this with technology today. In about 3 or 4 lessons in my class, we're going to also do this by hand using an algebraic technique. But you're happy about the technology part because it's super, super easy. So, just as a refresher, the definite integral, we'll do indefinite integrals later, is the area under the curve for a function, and this equals the distance on a velocity versus time graph. So not a distance versus time, which you might be familiar with, but this is a graph of velocity as it changes in time. So whatever that curve is, the distance traveled will be the area under that curve. Pretty cool thing. Okay, quick refresher on the notation. Our little curvy integral sign. This means the integral from A to B, these are the x coordinates in the function of f of x dx. And remember, the dx stands for with respect to x. So we're going to take that and put some numbers in there and do a problem. Okay, here's our integral from 0 to 2 of x squared plus 1 dx. Now, up until now, we've done integrals with functions that created geometric shapes that we could use formulae on to calculate the area under the curve. But that's a quadratic, so it's going to be a curve that we're finding the area underneath. So the previous techniques that we use aren't going to work in this one. So what really helps is to make a graph. In fact, you're going to be prompted from time to time to make a graph. So take a look at that function, x squared plus 1, and see if you can come up with the graph. Okay. This is just a pretty straightforward parabola. We have our vertexes at 0, 1. So here's my vertex at 0, 1. Now I'm only drawing the part of the parabola that's specified by my range. So I'm starting at 0 and I'm ending at 2. So this is just a part of the right side curve, the increasing curve of the parabolic function. When I put 2 into the function, it spits out 5. So that's why I know that this point here is 2, 5. And then of course I shaded the area under my curve, and this is what this is asking for. The integration of this function from 0 to 2 is answering the question, what is this area? And you can see right now that we cannot use our prior techniques to do this problem. Okay. I've got some calculator click steps for you. If this doesn't work for you, then I suggest you go on YouTube and just Google using the TI-84 or the TI-Nspire with integrals, and you're going to find tons of videos that will help you do that. So on the 84, you press the math button, then you press FN int, and then basically you're going to get a screen that allows you to put in this, this, and this, and that. And that's all you've got to do, and it will give you your value of this integral. Now on the Nspire, it's a little different click path, but it's the same result. You want to get into the calculate section, press menu, select calculus, go to integral, and then it's going to be the same thing. You're going to get something like this. It has a little box there, a little box there, a box there, and a box there. And you just put in your information. And the box that's there is for the x. So you do want to say dx. You're saying you're integrating this function with respect to x. So that's an important piece of information that you need to provide. So what I want you to do is pull out your trusty calculator and do this calculation and then come back. Okay, let's see how you did. When I put it into my calculator, I get 4.666 forever. So 3 sig figs makes it 4.67. So that is the area underneath this curve. Okay, we're going to finish up this lesson with 2 problems that have the same prompt. So let's take a look at the prompt. It's pretty straightforward. In the following, write the definite integral and find the area. So for me, I'm going to also throw in one more step, is sketch the function. So we're going to start with that. So my function here is f of x equals negative x plus 2 times x minus 3, and it's bounded by the y-axis and the line x equals 1. So again, we're giving you a function that's hard to visualize, so you need to take a look at the graph so you can figure out what your a and your b terms are. So pause the video and draw your graph. Okay, here's my graph. I know that my x-intercepts are -2 and +3, and I know this is a downward pointing parabola, so I just sketched it like that, going through -2, 0, and going through 3, 0. And that's really all I need. So now, time to shade the region. And so you got to pay attention to what this asks you to shade, and I think this is the hard part of this problem. So pause the video and take your best stab at that. Okay, so check this one out. Here's the line x equals 1. Remember, x equals something is always a vertical line, and then the y-axis is just the x equals 0 line, or the y-axis. So then I shaded this area in between the two. So there is the full graph of the situation. So now, pause the video and do this step. Write the definite integral. Okay, that step is pretty straightforward. From 0 to 1 of our function minus x plus 2 times x minus 3 dx. So there is my integral in integral notation. Now pause the video, use your technology, and find out what the value of that integral is. All right, when I put it in my calculator, I get 6.17. Make sure you can get that. If you're struggling with that, go back, try it again. If you can't get it, pull up a video that teaches that section, like on YouTube, and I'm sure you can get it. Also, if your calculator is different from the two I mentioned, then you will have to dig in and do a little bit of research for how to find the definite integral. All right, so same prompt, write the integral, find the area. So here's our function, 1 over x squared plus 1. This is a rational function. These get a little tricky to make hand graphs. So in this case, I just pulled out my calculator and made my graph, and then I'll transfer it onto the screen for you. So go ahead, pause the video and do that. Okay, so here's my graph right out of my calculator. This function makes sort of it looks kind of like a bell-shaped curve. Maybe it actually is a bell-shaped curve. And then I shaded my region for my interval. So x has to be greater than -1 and less than 1. So notice how that's specified a little differently than we specified things before. So here's my graph, there's my area. Now write the definite integral. All right, here we go. From -1 to 1, the integral of 1 over x squared plus 1 dx. So pretty straightforward. By now these should be pretty easy to do. Pause the video, pull out your calculator, and find the value of that integral, as in find the area under that curve. All right, when I do my calculation, I get 1.57. So that is that area. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that didn't go in so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.